All right, so I guess 10.3 is going to be 3 parts. Go figure. This is how it is going to be, guys. Sorry. I just noticed I thought I was done, and then I noticed one typo that is kind of a critical flaw, but this is why we check things. So it is true when I look at this ratio that a sub n is larger, specifically since they have the same sign. The nth term, I should say that the absolute value of a sub n is going to be larger, because if they both are negative, a sub n, I'm getting a positive term just because I'm dividing two negative numbers. Why does that matter? Well, because we need to be careful here. I was like, everything I've done is technically correct, but we got to be careful. So let's look at our term-by-term analysis. It is true that 0.00050 is more than 0.0001. That is true. However, notice we are subtracting things. And so since a has lower degree terms, it is larger for x near 0. So we should modify this to say that since a sub n, the absolute value of it has lower degrees terms, it is larger for x near 0. However, this means that the negative absolute value of a sub n is actually going to be less than the negative absolute value of some b sub n. Like what I'm saying here is, if we look at these first two terms, this first term here without the negative is more, but that means that if I am subtracting it, I am taking more away. B, this x cubed, that x cubed is going to be less, but I am subtracting it, so it's actually going to be more. So the result of this is that thus b sub n, our b series, we'll say the actual name, what was our b series? Our b series was, I lost track of all my work, x over e to the x squared. Thus x e to the negative x squared is larger for x near 0. So we have to tweak that. And then let's go to the ratio analysis. So at this point we worked all the way through it. Again, all the work is correct. I didn't notice until the very end, and that's why these are so tricky, is we have to think about, like, it's one thing if they're all positives or negatives, but if they're alternating, not only do we have to think about the size of each term, but we have to think about what that means for negatives. The absolute value of a sub n is larger, but again, this means that if that larger term is negative, if the term is larger but it's negative, then it is going to in fact be taking more away than it would be to use the smaller b sub n and subtract that. And thus again, b sub n, or not b sub n, our series b, so x e to the negative x squared is larger for x near 0. And what made me realize this really important typo right at the very end, or basically this lack of detail, is let's do a check, right? Check the graphs. This is always a good idea. And because we are doing a nice recording, and I'm going to post this on YouTube, I get to cheat and use my GeoGebra rather than having to sketch it on a board. Here is these two functions we've been writing with Taylor series. Notice that as a whole, 1 minus e to the negative x is going to be larger. But we care about x near 0. We care about, whoops, not that way. We care about this window right here. And if we look at this window here, for at least a little while, the blue line is definitely larger. So, and we also said for positive x. So the blue line is definitely going to be larger, and that's because, again, our terms in our green series, we are subtracting larger numbers than we are for the blue one. So the green series, we subtract larger numbers at the beginning, and that puts us lower than it. Notice also that in the problem I said for x near 0 that we're positive, and that was because if I said x near 0, notice the roles switch when we go to the negative side. So there's like all sorts of switching around happening here. If I go to the negative side, then again we are make sure I say this right. If we go on the negative side, then I will be subtracting. Yeah. Actually, no, that would work. So notice the blue line is actually more in both directions. So if I'm on the negative side, the blue line is still higher than the green line. And that's because, again, in the negative direction, I would be still subtracting larger amounts for that first term, which is going to make the green line less than. Yeah. So for x near 0, the blue line, or x e to the x squared, is greater. And we can see that graphically, and it makes sense with our ratio analysis and our term-by-term analysis. But it's just really important to keep track of when you're doing term-by-term here, these negatives right here, right? Because if they were just positives, then the A series would be bigger, but by subtracting bigger things from the A series, I'm actually making it smaller, which is a little counterintuitive. And when we think about alternating series, once I've subtracted off more from that first term, I never really get it back. I can think about how the alternating series, how we flip back and forth, how the alternating series went over here, but then we subtracted some, but then we went back, and then we subtracted some, and then we went back. We were kind of bound in this pyramid. That is a good, like, intuitive explanation of why we really care specifically about, like, the first 3 terms. So, like a note, we really care because if I think about the alternating series, a lot of the behavior for the overall series is going to be defined by that very, like, first 2 arrows. How much I add and then how much I subtract in that, like, first 2 steps is really going to have an impact on the following terms afterwards. So it's really important when you're doing this, if you're going to do term by term, to just think about the very beginning ones. Okay, and with that, 10.3 is